Okay, in this lecture video, we're going to talk about other inhibitors of enzyme activity. So now we're not going to talk about molecules like drugs, but we're going to talk about environmental conditions. So first of all, we're going to talk about pH, and then we're going to talk about temperature. So if we look at a plot of pH on the x-axis and enzyme activity, so how functional it is on the y-axis, we get something like this. So you get this region, or this area, where you've got maximum activity of the enzyme, and that activity falls off as you decrease the pH or increase the pH. And we can explain this based on changes in protonation state of catalytic residues. So for example, if you have an aspartate residue that has an active carboxylate, right, on the end that's participating in chemistry, and you drop the pH and this carboxylate gets protonated to a carboxylic acid, it's no longer going to be able to do the same chemistry that it could do as a carboxylate anion. And you can make the same type of argument for increases in pH in other types of functional groups. So for temperature, make the same plot for temperature and enzyme activity. We get the same shape, where again you have this region of temperature of this maximum activity. And what we can think about there is at lower temperatures than the optimal enzyme activity, we can think about the enzyme as just going slower. We know that if you drop the temperature of a chemical reaction, that chemistry is just going to go slower. On the other hand, if you raise the temperature, now we're talking about a case where the enzyme is going to start denaturing. You're going to start breaking all of those non-covalent interactions that are holding that enzyme in its correct tertiary structure or even quaternary structure. And as that enzyme unfolds from its native structure, it's going to be unable to perform its catalytic function. So these are examples of how environmental conditions can inhibit enzyme activity.